the first thing I want to announce is that the former chair of the meeting, Jack Gaffey, died November 29 from, well, he was having therapy for cancer, and he died of covert complications. So we're all very saddened from that. And so at least for the time being, I've taken over for him, and my name is Don Novotny. Anyway, we have a tentative talk for, I guess, January 18. Which will be on the DART project given by, oh goodness, Peter Cheng from Johns Hopkins Applied Physics Lab. And
Andrew Chang.
Andrew Chang.
What did I say? I'm sorry.
You said Peter.
Oh, okay. Oh, okay. Sorry about that. Okay. And we did have this talk announced in the Stardust newsletter, which is the National Capital Astronomers newsletter. And let's see, the other thing is that we announced that we generally have our talks on the third Wednesday of the month, and that we have a planning meeting on the first Thursday of the month, and everyone is welcome to come. There is no attendance taken or anything like that. You can come, you can share your thoughts, you can suggest talks. In fact, we would be happy to have talks suggested. So with that, the usual procedure was for us to go through the people and have them introduce themselves. I already told you my name is Don Novotny, and I'm retired from NIST, National Institute of Standards and Technology. So, Flash, you want to go next?
Yes, I'm Howard Gordon, known as Flash, and I'm retired from the National Security Agency.
Okay, Robert?
I'm Bob Ehrlich, and I'm a retired professor of physics from George Mason University.
Okay, David?
Yes, I'm Dave Ryan. Bob and I have, I don't remember if we met very much when I was at GMU, George Mason University, but my field is applied mathematics and system engineering. And I was a really good friend of my astrophysics friend at George Mason University, John Evans, a number of years ago. And he and I used to collaborate on some astrophysics problems and issues. So that's enough for me.
Okay. Jay?
Jay Miller, retired biophysics, retired from National Institutes of Health.
Okay, Paul?
I'm Paul Rodriguez, and I'm retired from Naval Research Laboratory, where most of my work was in plasma physics.
Okay, Harold?
I'm not retired. I'm the planetarium director at Montgomery College, and right now I don't have a planetarium, but I will have one later this coming year. I also teach astronomy. I'm also the Science, Engineering, and Technology Laboratory Coordinator. And I've heard Mario Livio speak before. He's an incredible speaker.
Okay, let's see. Harold Giller?
Sorry, I was unmuted and off video. I'm also emeritus from George Mason University Physics Department, but I'm keeping myself busy by doing some adjunct as teaching physics at George Mason University and also at American University in DC.
Okay, let's see. Martha?
I'm Martha Raup. I'm an associate of Howard Flash Gordon's at the National Active and Retired Federal Employees. I'm a retired letter carrier from San Francisco.
Okay, let's see. Jay Shapiro, did we get you?
Not yet. Hi, I'm
Okay.
Jay. I'm on mute. Oops, I have to stop my video. I'm Jay Shapiro, retired mathematician from George Mason University with my wife, Diane. I have read at least one of Mario's books and I'm looking forward to the talk.
Okay, I don't know if I missed anyone or not, but Jerry, you want to introduce yourself and our speaker?
Okay, I'm Gerard Stenbakken, Jerry Stenbakken, and I worked at National Institute of Standards and Technology for 40 years. And I have a great pleasure of introducing Dr. Mario Livio. He's an internationally known astrophysicist, a best-selling author and popular speaker. He's a fellow of the American Association for the Advancement of Science and has published more than 500 scientific papers on topics ranging from dark energy and cosmology to black holes and extrasolar planets. He is the author of 7 popular science books, including one that I read and enjoyed, The Golden Ratio. That was an international bestseller for Pythagorean Prize. Another book is God a Mathematician, which was the basis for the 2016 Emmy-nominated NOVA program, The Great Math Mystery, and Brilliant Blunders, which was a national bestseller and selected by the Washington Post as one of the best books of the year. His latest book is Galileo and the Science Deniers, which is his topic for today. So, Dr. Livio.
Thank you very much. So let's start. Galileo and the Science Deniers. The first thing I did, Galileo was, wait, there is something here that stops me from advancing. Why is that? Okay, I'll advance like this. Can you all see the slides and everything? Yes, okay.
So far, I think so.
Yes, okay. So, yeah, Galileo is really one of those really larger than life figures. So the first thing I did was, like you have a photo album, you take your photograph and you sort of throw them one on top of the other and try to look at them. And that's what I did. This is the very earliest portrait that we have of Galileo. It was done when he was in his 30s by an unknown Tuscan artist. You may notice that there is a certain asymmetry in his eyes, which actually persisted. And the last 4 years of his life he was actually totally blind. Here he was in his 40s. This was painted by a somewhat better known painter, Tintoretto, but not the great Tintoretto, not Jacopo Tintoretto, but his son. Who is less great, and also it's only attributed to him. We're not sure whether that was really by him. This is the best known portrait of Galileo by Sustermans. It's in the Uffizi Gallery in Florence, and here he's holding the telescope you see in his hand. Now, today we can use some AI tools and bring even Galileo back to life. So if you look at this thing, just look at him. He is coming back to life. You see, he's moving. He's at the end, he's even smiling a little bit. So we can do all kinds of tricks with AI, some good, some perhaps less good. Now, there are other paintings showing Galileo doing various things. Here he's demonstrating his telescope to the Doge of Venice. This is a cartoon from just the last century where he tries to explain his discoveries to the people from the Catholic Church. And, he's so famous that he went even into pop art. Here, a pop artist, took one of his portraits and created this sort of op art rendition of Galileo. And like I do whenever I write a book, is I actually go to the places where the people lived or worked. And walking the streets of Florence, I actually discovered that even graffiti artists decided to take Galileo as a subject. And this was actually, believe it or not, on the back wall of the Galileo Museum in Florence. Somebody painted this thing. Now, Galileo himself never did much diving. And so this, of course, is anachronistic, but it's still interesting. Now, it's not just in paintings, it's in many other areas that Galileo is famous. Google devoted one of their famous doodles to the invention of the telescope. There is a very famous play by Bertolt Brecht, Life of Galileo, which has been actually quite influential, even though some of the historical details depicted in the play are not precise, but nevertheless, it's an important play. And there is even an opera called Galileo by Philip Glass. And actually, this is from one of the performances. And and in the opera itself, they actually even show some of his experiments and things like that during the opera. Now, again, Galileo is so famous that there are many stories about him, not all true. Some of them are just myths. Vincenzo Viviani was a student of Galileo, a mathematician himself, and he also was his assistant, and he lived with him during the last few years of Galileo's life. And he wrote the very first biography of Galileo that we know of. And in that biography, he has certain stories. So one story is related to this lamp, which heads in the cathedral in Pisa. And the story that Viviani tells us is that Galileo was watching this lamp swing from side to side. And by counting his heartbeats, he realized that the period of the swing is independent of the amplitude, which we know is true as long as the amplitude is not too large. And that Galileo used this fact, Viviani tells us, to construct some device to measure the heart rate of people. Now, this is a very nice story. There are, however, a few small problems with it. One is that this lamp that Viviani talks about, and he tells us that Galileo was 19 when he watched it, was actually installed in the cathedral only 4 years later than when Viviani tells us that Galileo watched it. Now, of course, it's possible that there was another lamp hung in this place earlier, but what is certainly true is that Galileo did not invent that pulse measuring device, because Galileo was always extremely aggressive when somebody tried to take credit from him. And actually a doctor named Santori did invent such a machine some years later, but Galileo never complained. So it probably, the story is nice, but it probably never happened. Nonetheless, the story is sufficiently famous that it made it into various paintings, which show, for example, here, young Galileo looking at this lamp before him and so on, according to the story. Another story is that Galileo dropped balls from the Leaning Tower of Pisa to show that balls of different masses fall at the same rate. Basically, at the time, the prevailing theory was that all the way back to Aristotle, which claimed that heavier bodies fall faster than lighter bodies and infecting a speed that's proportional to the weight. Galileo claimed, on the other hand, that there is air resistance, but that without that, balls of different masses free fall at precisely the same rate. And he actually did many experiments to demonstrate that, which he documents very nicely, only he didn't do any from the Leaning Tower of Pisa. And again, there were others actually who did experiments from the Leaning Tower, but not Galileo. But again, the story became so famous that you see in this painting, even the Grand Duke is attending the demonstration by Galileo dropping balls from the Leaning Tower. So that's another myth, even though, like I say, Galileo actually did many experiments in which he dropped balls from various heights to show that they drop at the same rate. The biggest story that is interesting is the story that after his trial, and we will talk about his trial in a little bit, by the Inquisition, when Galileo was found guilty because he claimed that the earth moves, he was found guilty, and then story goes that after the trial, he stamped with his foot in front of the Inquisition and said, "And yet it moves," meaning the earth. Now, of course, he didn't speak English, so he said in Italian, "Eppur si muove," which means, "and yet it moves." Now, while writing the book, I became very obsessed with trying to find out what is the evidence for Galileo having ever said this. And luckily for me, Favaro, who did the most extensive biography of Galileo, already did some work by himself, so I could rely on him as well. So here is the story. I mean, this, by the way, took me more than a year, this research just into this thing alone. The first appearance in print of this phrase, of this motto, "and yet it moves," "Eppur si muove," appears in the middle of the 18th century, more than 100 years after Galileo's death. And it appears in a text by an Italian, which is full of things which are incorrect. So if it were just that, we would have definitely said, well, it's just a myth. But something happened in 1911. In 1911, a Belgian gentleman, actually physicist, wrote to Favaro and told him that he owns a painting, which, by the way, is identical to the painting that you are watching, but it's not this painting, because I'll tell you in a moment something different, but it's identical to this one, that he owns a painting, which was painted just 2 years after Galileo's death, and which, the painting is called Galileo in Prison, and on the wall beside Galileo, there is a drawing of the earth moving around the sun, and you see that underneath it says "Eppur si muove," namely this famous phrase, "and yet it moves." Now, you see, the claim was that this painting was from just 2 years after Galileo's death. And if this were true, then this, would have very likely meant that Galileo indeed used this phrase, because if it was known, just as soon as he died, then this was probably true. And indeed, many science historians concluded from this that Galileo indeed probably said this phrase, even though, of course, nobody thought he said it in front of the Inquisition at the end of the trial. This would have been suicidal on his part. But that he said it under some circumstances. Okay, so that was all very nice. But then, I started looking at the story of this painting, and I discovered that even though this painting was definitely seen in 1911, there was another person who actually traveled especially to see it and so on. The whereabouts of this painting were unknown since 1911. So that became intriguing, and I started, looking for it in various ways. And after a lot of effort, I discovered that it was exhibited again by that same Belgian gentleman in 1936 in Antwerp. That painting was exhibited again, but then again it disappeared. I mean, nobody knew where it was. So here there were various possibilities. I mean, there was a possibility that maybe the painting was destroyed in the Second World War. There was a possibility that the painting, whoever inherited the possessions of that Belgian, whose name was Van Belle, had it, and things like that. While researching this, I discovered something really strange. And that was, I discovered the painting which you see on the left, which I showed you, which has this writing on it, in a museum in Belgium. But this painting was actually painted by a Flemish painter named Van Maldegem in the middle of the 19th century. And Van Maldegem was a fairly known Flemish painter, and there was absolutely no indication that he painted this, copying some other existing painting. In fact, in a catalog that was published while Van Maldegem was still alive, it was listed as an original painting by him. And this painting is identical to the one that Van Belle showed, because we have pictures of the painting that Van Belle showed. So this already became very suspicious, this entire thing. And nevertheless, still nobody knew what happened to that painting that Van Belle showed, because he had it, and it wasn't this one, which was hanging all the time in this museum. Well, to make a long story short, I will tell you that I discovered that the painting that Van Belle owned was inherited by his niece, and from there, 2 generations later, in 2007, the painting was sold at an auction. That particular painting. By the way, Van Belle claimed that that painting was painted by a very famous, he had a whole story with it. It was painted by a Spanish painter, and I contacted 4 experts of that Spanish painter, that was Murillo, and they all confirmed that that painting was not painted by Murillo, and so on. Bottom line, it is, I would say, 99% certain that the painting that Van Belle had was a copy of the Van Maldegem painting, which was painted in the middle of the 19th century. And therefore, indeed, the very first mention of this phrase, pur si muove, came more than 100 years after Galileo's death, and he never said it. Now, this doesn't mean he didn't think that. He definitely was very, very upset about being sentenced and all that. So he certainly thought that, but he never used this particular phrase. Let's now move from myths to actual things that Galileo did. So one thing, he indeed wanted to show that masses of different values fall at the same rate. But you see, there weren't good clocks at the time. So if you drop something from not too high, to see whether they arrived together or not was difficult with existing time measuring devices. So he found this extremely clever idea, instead of letting the balls drop, to roll them down an inclined plane. And by making the angle of the inclined plane very small, he considerably slowed down the motion. If you like, he diluted gravity and was able to measure things much better. And in doing so, he discovered one of the very first mathematical laws of motion. Namely, he discovered that in free fall, the distance that bodies travel is proportional to the square of time. As we all know, yes, you know, half GT squared and so on. So this was a mathematical law that he discovered, and this was a great discovery. A second thing that he discovered is by allowing the balls to roll down and then sort of move through the air, and by tracing the trajectory of these projectiles in air, he discovered that the trajectory is actually a curve known since antiquity, namely a parabola. So he again showed that projectiles in the air move on parabolic trajectories, and that was again a great discovery. Now, of course, Galileo's greatest discoveries were done with a telescope. Now, some people think that Galileo invented the telescope. No, he didn't. The telescope was invented in the Netherlands, but as soon as Galileo heard about this, he started constructing his own telescopes. And these are two of his original telescopes. Well, only two are survived to today. And they are, again, in the Galileo Museum in Florence. He constructed his first telescopes by actually taking organ tubes and putting lenses on both sides. And he polished his own lenses. And so, as a result of that, you know, the available telescopes at the time had a power of about 4. He very quickly reached powers more than 20. So he had very high quality, well, for the time, telescopes. And like I said, he polished his own lenses. This is one of his original lenses here, well, embedded in a very ornate frame, but the lens in the middle, that's a lens that Galileo polished by himself. Now, once he had this telescope, he had to decide what to do with it. And instead of, let's say, spying on his neighbors or watching ships arrive to Venice, he instead turned it to the moon. And then he drew what he saw with his observations of the moon. Now, all of these are drawings by Galileo himself. On the left-hand side, there are wash drawings, and on the right-hand side, you know, etchings. And what you see here is something actually amazing. You see, Galileo, as a young person, was trained in drawing. He was actually at the school of drawing. So he was trained in art. And the fact that he was trained in art allowed him to understand what he was seeing when he looked at the moon, because he knew, you know, he knew the light and shadow. So he immediately understood that what he's seeing is that the surface of the moon is not smooth, but rather covered with mountains and craters and hills and whatnot. And he drew them very, very accurately. You see, at the same time, there was this English mathematician and astronomer Harriot, who also observed the moon with a telescope. But when he tried to draw it, it was just some like squiggles, you know, that you cannot understand what you're seeing even. But Galileo here used his art to make this beautiful drawing. If you look on the left-hand side, the bottom right figure, the one marked with the number 3, you will see that in the unilluminated side of the moon, you actually see a few points of light. Galileo understood, for example, that those were the tops of mountains that were actually lit up, and then the light, you know, was creeping down those mountains. So here, his art and science, you know, played against one another to allow him to understand what he was seeing. Now, of course, today we know that Galileo was right. This photo was taken by astronaut Bill Anders from an orbit around the moon. It's called Earthrise. And you see the hills, of course, and craters down. And by now we have even better such photos taken from a Japanese satellite. And you see all the craters and the hills and the things on the surface of the moon and the Earth rising in the background. Now, next thing here, I'm going to show you a short video. The video is of very poor quality because it was filmed on the moon by astronaut Dave Scott. And the sound is also not great, but hopefully you will understand what he is saying. So did you hear him okay? I mean, could you understand what he said? Yes or no? Well, basically he had a feather and a hammer and he dropped them. He said, you know, one of the reasons we're here today is because of a certain gentleman named Galileo who made some discoveries about falling objects, and he dropped the hammer and the feather. And of course, the moon has almost no atmosphere whatsoever, so the feather and the hammer hit the ground at the same time. And he said, so Mr. Galileo was correct. Okay. This, until 5 months ago, this letter of Galileo to the Doge of Venice was thought to be the very first document that showed his results from observations of the planet Jupiter. Here at the bottom of this thing, you can see Jupiter and some objects next to it, which sometimes it shows 4, sometimes 3, 2, 2 on one side, 2 on the other side, and so on. The reason I say it was thought to be the very first document is because about 5 months ago, actually a historian at Georgia Tech showed that this particular document is a forgery from the beginning of the 20th century. But nevertheless, the results were the true results, and Galileo described them in his book, Sidereus Nuncius, where you can see, you know, these objects around Jupiter. And very quickly, Galileo realized that what he discovered was satellites of Jupiter. And these are the objects today we call the Galilean satellites of Jupiter. Of course, Jupiter has many more moons than what Galileo could see. There are actually 79 named moons now of Jupiter, but he saw these 4 and even measure their orbits to astonishing precision of, his error is not larger than a few minutes in the worst cases. So that was that. What is less known is that Galileo was the first person to detect the planet Neptune. This is that point to the very far left in this figure. Now, he didn't recognize it as a planet because his observations weren't sufficiently precise to tell that it moves, but he did see it in 1612. Neptune, of course, was discovered only in the middle of the 19th century, actually. One of Galileo's most important discoveries was the phases of Venus. You see, the point is the following. There were 2 models for the solar system at the time. One was the old Ptolemaic Aristotle model, which said that the Earth was at the center and everything revolved around the Earth. And then there was the Copernican model, which Galileo adopted, which said that all the planets revolve around the sun. Now, Venus is always, somewhere between us and the sun. And so the prediction was that if indeed Venus revolves around the sun, then you should see something like what you see here, namely, when Venus is the farthest from us, as it is at the top of this figure, it should look the smallest and fully lit. When it is closest to us, as it is at the bottom of this figure, it should be large and dark. And in between, it should show phases just like the moon. And Galileo actually showed that all of this is seen. This does not happen if everything revolves around the Earth. So this was a big killer for the Ptolemaic Aristotelian model of the solar system. Now, I want to make a certain point here. Galileo actually never, even though he thought he did, he never managed to prove that the Earth actually moves. He thought he did because he thought that from his theory of tides, sea tides, he can show that the Earth is moving, but his model for tides was completely wrong. He also thought that he proved it from following the paths of sunspots. And actually one can prove it from that, only Galileo did not have enough mathematics to be able to show that at the time. So while he did basically kill the old Ptolemaic model, he couldn't totally refute a hybrid model suggested by the Danish astronomer Tycho Brahe, which suggested that all the other planets revolve around the sun, but the sun itself revolves around the Earth. That Galileo couldn't kill, but he never considered it seriously because he thought, that had too many moving parts, basically. So he didn't like that model at all. Okay. Yeah, I mentioned the sunspots. One other thing that Galileo did, this of course is a photo not from the time of Galileo, it's a modern photo, but it shows the Milky Way. Basically, Galileo, by turning his telescope to the Milky Way, he showed that what appeared to the naked eye as, it's also almost a continuous band of luminous light, broke up into many, many hundreds of stars of different brightnesses and so on. So basically, this was the first time that humans, looked outside the solar system into our galaxy. I want to change now direction a little bit and talk about something else which is kind of dear to my heart, and that's the following. There was this chemist and writer, C.P. Snow, who lived in England, and in around 1950, he realized that starting from the 1930s or so, people from the humanities in England started referring to themselves as the intellectuals, thereby excluding scientists from this definition. And not only that, these so-called intellectuals mocked scientists because they said that they were quite ignorant in, knowing the literature, the arts, and so on. At the same time, C.P. Snow noticed that, again, these intellectuals from the humanities didn't know anything about science, and that somehow didn't bother them. He tried asking them, what is an acceleration? What do they know about mass? And they knew nothing. So he wrote this book, which he called The Two Cultures, where he lamented the fact that, in his opinion, something like a big gap has developed between the sciences and the humanities. Now, there are people who, many people who today claim that this gap or, this is even larger today. Others claim that it's somewhat narrowed. But my point is that Galileo would not have even understood what people are talking about. You see, Galileo grew up in Florence, and there, he looked one side of the Arno River. He saw the Ponte Vecchio, the old bridge, with this beauty. The other side, enormous beauty. There was just beauty around him. And he, as I said, he studied art. I mean, even the pizzas in Florence look sometimes gorgeous like this. So he studied art at the beginning, and at the age of 24, for example, he was invited by the Florentine Academy to give 2 talks on the location and structure of Dante's Inferno. Dante wrote the Divine Comedy, part of which is the Inferno. This is a drawing by Botticelli, of that thing. And Galileo gave 2 talks. Now, mind you, he actually made a serious mistake in his talk, which he corrected only much later in life. But the fact is that he knew to cite Dante by heart. He knew this poet, Ariosto. He even wrote a whole essay comparing Ariosto to Tasso. He thought that Ariosto was far superior, and so on. He had painter friends. The painter Cigoli was a personal friend of his. Cigoli painted this, ceiling in the Santa Maria Maggiore. This is in Rome. And I want to draw your attention to the at the bottom of this thing, which shows the Virgin standing on the moon. And the point is to look at what the moon looks like. You see, Cigoli observed the moon with Galileo. And so all the people who painted this scene from Revelations before Cigoli painted the moon as some sort of a pristine, completely free of blemishes sphere. Cigoli painted Galileo's moon with the craters and things and blemishes. So this was one of his friends. Another friend of his was painter Artemisia Gentileschi, one of the great painters of the Renaissance. There were a few, not too many, but a few great female painters during the Renaissance, and she's one of them. And here is her painting of Judith beheading Holofernes. And this was the first version that she painted of this. And I want to draw your attention to where is the head of Holofernes at the bottom of this. Story has it that, she corresponded with Galileo quite frequently. And at one point, Galileo told her about this business that projectiles in the air follow parabolic orbits. So when she painted a second version of Judith beheading Holofernes, look, she painted the blood squirting from Holofernes' neck, and the blood follows parabolic orbits, just as Galileo told her. And this was her second version of Judith beheading Holofernes. I don't want to give you the impression that Galileo was the nicest person. He was very supportive to his family, and he had a few very good friends. But good Lord, to his enemies or people who disagreed with him, he could be really sharp. And at one point, there was a mathematician at the Collegio Romano named Grassi, with whom Galileo had a disagreement, for example, on the nature of comets. By the way, Grassi was right, Galileo was wrong. But also they discussed heat. Grassi was unfortunate enough to publish a book about heat, where he cited a story that came from a Greek historian that said that the ancient Babylonians used to cook their eggs by whirling them very fast on a sling. Galileo was very happy to hear that. And he wrote this book, Il Saggiatore, the Assayer, where he just, mocked Grassi to death about that story. And I want to give you an idea of, the type of sarcasm that Galileo used. You see, Galileo said like this, he said, "Oh, Grassi tells us that the Babylonians cooked their eggs by whirling fast on slings. Oh, I'm willing to believe that. But let's see, when we do this, it doesn't happen. If anything, if the eggs were hot to begin with, they will cool down when we do that. So let's try to see what is different between what we do and what the Babylonians do. And if we will find that there is only one thing that's different, then that must be the cause for the difference. So let's see. The Babylonians had eggs, we have eggs. The Babylonians had slings, we have slings. The Babylonians had strong fellows who can whirl the thing very fast, we have that too. So what's the difference? He said, the one difference is that we are not Babylonians. So what that means is that what cooks the eggs is being a Babylonian. So that was the type of sarcasm that he used. And actually the Pope was so impressed with his sarcasm that he actually had pieces from the Assayer read to him at breakfast. Now I'm jumping a couple of decades in the history and to this book that Galileo wanted to publish, the dialogue on the two world systems. So this book was written as a conversation among three people. One of them was sort of a stand-in for Galileo himself, who represented the Copernican view. A second was sort of a neutral, a non-scientist but educated person. And the third was somebody who supported the Aristotelian or Ptolemaic system of an Earth-centric thing. Now, in the whole book, Galileo mocks the Aristotelian to death, just tears him to pieces and so on. But Galileo still had to publish this book, and to publish it, he had to get the imprimatur, to get the permission of the Pope to publish it. So his friends suggested to him that he would add a preface and the conclusion, to soften what he was saying. So basically he added the preface and conclusion, which negated almost everything that was in the book, basically saying, oh, well, yeah, we say this, but, God is almighty and he could do things however he wanted. And so we really don't know. And he actually got permission to publish this. The problem was that anybody who actually read the book could see what Galileo was really thinking, and that the preface and the conclusions were really some sort of afterthought. So Galileo was actually put on trial. I should say that 17 years before this, the head of the Inquisition had an injunction on Galileo, which said that he wasn't allowed to hold, teach, or discuss the Copernican model. Now, Galileo himself had a letter from the chief cardinal, Roberto Bellarmino, which used a somewhat softer language, which said that he couldn't hold the Copernican views, but it didn't say that he couldn't teach or discuss them and so on. So he thought he was okay by writing this book, but the church didn't agree and put him on trial. And Galileo's main argument in all of this was that, look, the Bible is not a science book. The point is the following. Very often, the entire Galileo affair is presented as if it is a clash between science and religion. It wasn't, and Galileo never saw it as such. Galileo said that the Bible can never be wrong. So what was the clash? The clash was between scientific findings and literal interpretations of scripture. And that was, Galileo said, when there appears to be a clash between literal interpretation of scripture and science, then it means that our interpretation is wrong and we have to change that. So he gave as evidence for that the following fact. He said the Bible was not written to teach us science, it was written for our salvation. Whether or not the earth moves or the sun moves at all, it is completely irrelevant to morality, to ethics, and so on. So that doesn't count. Another reason that the Bible is not a science book is that, look, I mean, even the planets are not even mentioned by name in the Bible. So it wasn't meant to teach us science. And finally, his strongest, statement was that he did not think that the same God who gave us reason and intelligence and so on wanted us to abandon their use. Now, all of this did not help, and Galileo was found guilty. He was found vehemently suspected of heresy. Vehemently suspected of heresy. There are many paintings that try to paint the trial. This is one of them. There are many people in attendance. It wasn't like this. It wasn't even like this. I mean, not all the cardinals attended all the time. 7 cardinals attended when the verdict was read, but that was it. During the trial itself, it looked more like this. There was just the prosecutor, Maculano. There was a certain guy named Febe who took the notes, and there was somebody named Sinceri who asked the questions. That's all there was. Galileo was found guilty, as I said, vehemently suspected of heresy, and on his knees, which again is depicted in many paintings, was asked basically to abjure. So here is what the verdict was. He was found guilty, basically, and he had to be interrogated on his intention. What does that mean? To find out whether or not he was only vehemently suspected of heresy, but he basically made mistakes, or he actually was a heretic, in which case he would have been burnt at the stake, just as Giordano Bruno was in 1600 during Galileo's life. So that's basically was the thing. Today, we look at this and we say, the church was right to try Galileo in the sense that he disobeyed that injunction of 17 years earlier. But, think about this. I mean, let's suppose that Galileo was completely wrong and the earth did not revolve around the sun. So what? Okay, so he was wrong. Why wouldn't we be allowed to say that? We're allowed to be wrong. So in any case, that is what happened. And he, had on his knees to say that he detests and curses and everything that he said, basically taking back everything he did all of his life. One of the most horrible attacks on freedom of thought in the history of humanity. Now, what happened after all of this? Well, at some level, Galileo showed the church the finger. What I mean by that is that somebody, when his remains were moved from an obscure grave to the tomb in which he is today, somebody removed 2 fingers, a tooth and a vertebrae from Galileo, and the finger, Galileo's middle finger, is kept today at the Galileo Museum in Florence again. 350 years after the Galileo affair, Pope John Paul II finally declared in 1992 the following. He said that paradoxically, when you look at what Galileo was saying, the theologians were saying, Galileo was right because they didn't understand the difference between scripture and literal interpretations of it. Basically, precisely what Galileo was saying. It took 350 years, but they agreed that he was right. The current Pope Francis, here I am with Pope Francis, only that this is not the real Pope Francis, it's only a cardboard image of Pope Francis, which is not very far from where you are. It's at the Catholic University of America in DC, but it looks extraordinarily real. And if you actually would have seen the whole image all the way down, it almost looks as if we're holding hands. So anyhow, Pope Francis also agreed with Pope John Paul II and basically said that even the Big Bang and Darwinian evolution are not in contradiction to scripture. So Galileo won that battle. So I'm turning here from Galileo to something of today because you see, my book is called Galileo and the Science Deniers. And one of the reasons I wrote this book, other than the fact that I was always fascinated by Galileo, is that we unfortunately encounter incredible science denial today, largely in the US, but in other places, of course, as well. So I want to just make one point. And it has to do about climate. I'm not a climate scientist. I'm an astrophysicist. I'm not even an atmospheric scientist. So I chose something from the climate problem, which is easy enough for me to understand and explain. And that's the following. You see, what is depicted here is extremely precise measurements of the carbon dioxide concentration in the atmosphere in the past 50 years. And I don't even care so much about the values, but I want you to look at the slope of this. So this is past 50 years, and you can even see the daily variations here. This was measured extremely accurately in Hawaii. But we also have ice cores. Ice cores are taken from Antarctica, and they look something like this. And ice cores, you know, like tree rings, if you like, can tell us about the composition of the atmosphere at different times. For example, you see that dark ring in this ice core, and that's when there was a volcanic eruption, which threw lots of dust into the atmosphere. So we have these ice cores, and these ice cores, we have tens of thousands of them, and they cover an enormously long period of time. For example, here it is in the last 300 years. And what you see here is, I remind you that we had an industrial revolution. And from the industrial revolution on, you start seeing the CO2 going up. And then, you know, of course, it being extremely steep in the last 50 years. But we can go 10,000 years back and just look at the right-hand side to see how the slope changes. And believe it or not, there are ice cores go back 800,000 years. And yes, the carbon dioxide fluctuates and so on, but just look at what happens at the end. I mean, so, you know, I would say the following. I cannot prove that this is all human-made, but there is no doubt by looking at this in my mind that humans did not help this situation. So, you know, that's what I want to say. Now, what is the main lesson that we get from Galileo? This is Galileo's tomb. It is in Santa Croce in Florence. I am actually standing in front of this tomb. The tomb was actually paid for by Viviani. He left money when he died for Galileo to be moved to a very ornate tomb. Galileo's tomb, by the way, is just right across from that of Michelangelo, the artist. And what is the lesson here? The lesson here, to me, is the following. it is never a good idea to bet against the judgment of science. Why? Not because science is always right. In fact, scientists are very often the first ones to admit when they are wrong, but because science corrects itself all the time. Science, sometimes this takes a few years, sometimes take decades, sometimes it may take centuries, but it always eventually corrects itself. Now, it's never a good idea to bet against the judgment of science. Now, when you have situations where human life is at stake, as for example, in the case of the COVID pandemic, or when the future of the biosphere is at stake, as in the case of climate change, to bet against the judgment of science is just unconscionable. I would say it's almost insane to bet against the judgment of science in such cases. And that, I think, is really the main message for me from the Galileo story. So I want to thank you all for listening. This, of course, is all in my book. So I hope that you will read it, because there is always so much more in the book than I can tell in 1 hour. And you can read the book in English, you can read it in Hebrew, you can read it in Russian, in Italian, in Spanish, in Polish, even in Ukrainian by now, Spanish, Greek, German, Ukrainian. So you can read it in your favorite language. I'm not sure how easy it is to get a copy in Ukrainian, but it exists. On some Amazon, you can probably find it. So thank you very much. And if there are a few questions, I'll be happy to try to answer.
Yes, Mario, I do have one question. It goes like this. A number of years ago, I gave some lectures at the University of Milano, and while I was there, I also went to Pavia.
Yes.
And attended some lectures on Galileo and his poetry.
Yes.
Sort of the intersection, as it were, between poetry and music, and Galileo as the Renaissance man. We talked a little bit about his artistic work, but he did write some poems. I think some of them were a little controversial in the sense that I think one of them.
Yeah, one of them was very, how shall we put it?
Yeah.
Yeah. Yes.
Yeah, it got him in trouble. Yeah.
Yeah. One got him in trouble. Yeah. So indeed, so Galileo wrote some poetry. One of them got him in trouble. He was very much against rules which said, for example, that professors at the university at Pisa, whenever they appeared in public, they had to wear these gowns, and he was against that. And he wrote a whole poem, very long poem, actually, against that. Yes, he was a very, very good musician. He was actually played the lute. His father was a musician and music theorist, and his brother was a virtuoso with the lute. And Galileo himself played really well. He was an accomplished musician. So yeah, so he had all these other qualities. Yes, true.
One last comment about astronomy. The Pleiades are actually mentioned in one of the oldest books in the Jewish scriptures. So, maybe stars themselves aren't. Pleiades was mentioned. So it's kind of odd that you have this wonderful combination between poetry and music and mathematics, but yet they stumbled over what we can observe, which is basically the realm of science. It's just incredible that it took us so long to make that connection.
Yeah. Any other questions?
Yeah, I had a question or comment. I appreciated your comments about CP Snow and the separation of science and intellectuals. At NIST, we had a lecture back in I think it was somewhere in the 1980s. And I never quite understood what was happening because we had a Catholic astronomer come and give a lecture. And it was during the time that there was a lot of discussion about possible or some kind of apology from the church that was coming, but for their treatment of Galileo. But they had, as I found very interesting in your book, the fits and starts of making an apology and how to do it, how not to do it, and all of that. And we had this astronomer come to NIST, mention a little bit about Galileo, but at that time I knew very little about the whole process and what
you frozen me.
And I didn't understand why we were getting a lecture from a Catholic astronomer and you know, describing their work and what they were doing. But I see in retrospect, relative to C.P. Snow, what they were saying was that you can be a theologian and a scientist as well.
Yeah, look, I mean, the Vatican Observatory not only has had all kinds of scientists over the years, but they've also organized scientific meetings and things and so on. So that has happened, and apparently, as long as you understand this distinction between, like, what is the goal of Scripture, as opposed to, you know, literally interpreting every word that is written there, then I think that there is no contradiction, and people can be. I have had many colleagues who are, you know, either Jewish or Christian, who are extraordinarily good scientists and yet very religious people, and they saw no distinction, and, you know, no contradiction between their religion and their science. So clearly it is possible. Unfortunately, you know, at those times, and still, well, it's more unfortunate that still today there are some people who don't make that distinction. You know, people who talk about, you know, they don't agree to Darwinian evolution because it contradicts literal interpretations of the Bible. In the case of Galileo, you know, for example, one place where many of the people of his time were stuck on was that story of Joshua, who, you know, in his fight with the Canaanites, he says that the sun should stop at Gibeon, and, you know, and the moon in the Ayalon Valley. So they claimed that, it was the sun that stopped. So the sun was probably moving, you know, and so on. Galileo actually showed that that would have been horrible had the sun stopped, and that it is much easier to stop the earth simply so that the sun would not appear as if it's moving.
Oh, I have a question. You had no objection to us recording. Do you have any objection to us putting the recording on the Atlantic Senior Physics Group website?
No, I have no objection.
Okay, thank you.
Rudy, do you
Yeah.
have a question?
Can you hear me?
I
Yes.
can hear you. Yeah, I don't know who is talking, but I hear somebody talking.
Well, that's me. We have similar things today in what we call science. And we have various people, you say something and they say something, they will back it up by saying Einstein said so. And Einstein would have been the last person to use himself as the authority on something. In fact, a lot of people say that the speed of light is constant because Einstein said so. And in fact, in 1921, he said that there are situations that this is true in special relativity, but in general relativity, there's situations where it's not true. And I believe that Eddington showed that gravity bends a beam of light, and that shows that the speed of light is not constant because it always bends towards the slower areas with a slower wave speed with any wave propagation. So we are not out of the woods in terms of using authoritarianism as a justification for something.
I certainly agree with this statement. I'm not gonna talk about what you said about general versus special relativity. I mean,
that's what Einstein said.
Yes, but that's a somewhat different issue. I mean, the reason that light bends in gravity fields is because gravity is really only a manifestation of curvature of space. So that's what happens there. But it still remains true that the speed of light in a vacuum is the same no matter what.
Again, that's metaphysics, which means that it's a theory, a model on how things might work, but we can't prove it. We have physics and metaphysics, and
well,
there's a big difference between them.
Let's not discuss this here. This is not the right forum. I actually think that there are very serious experiments that test general relativity with enormous precision. I mean, for example, there are these lasers that are being shot at the moon, at these retroreflectors that Apollo scientists left on the moon. We have tested what happens to time, with things going one way and the other way. There were these atomic clocks. They were actually called whimsically Bob, Carroll, Ted, and Alice, which also showed we have tests that come from double pulsars and so on. So it's not, it's not true that we cannot test many of these things. In fact, most of them we can test. But let's not discuss this here. This is beside the point. Your main point that we shouldn't use authority, I completely agree with. We should, for everything, we should actually experiment on our own and find the correct answers and not use authority. I mean, we shouldn't say general relativity is correct because Einstein said so. That's definitely not the case.
And in fact, it was Copernicus who said that basically we have to look at things through our own eyes and not the eyes of ancient people.
Right.
I want to make one more question, and that is this. I've directed a large number of PhD students, and in every one of those good pieces of research, I think they're not too bad. I asked the people to write a rather substantial section on all of the possible biases that might exist in terms of their findings. And the other thing is that one of my mentors early on, Herb Simon, invented what he didn't really invent it. Other people have not. Basically, the whole idea of bounded rationality. And the exciting things about science is that our work is never completed. And there's always something to discover right around the corner. And yes, I agree with what the gentleman just said, in the sense that a lot of the previous work is, it's out of date, out of thought.
The thing is the following. You see, there are theories and models and things which are sometimes completely refuted by new work. Now, in the case of the best of theories, those are not thrown away. For example, when Einstein developed special and general relativity, this did not, some people say he refuted Newton. That's not actually true. I mean, Newton's theory is embedded now in a larger frame in which, Einstein's special relativity at the limit of very low speeds reduces to Newtonian theory, and the same for general relativity and so on. So the very best theories get expanded to a larger frame, which encompasses situations which weren't anticipated in the previous version. Now, of course, in some cases, things are completely refuted. Yes, I mean, cold fusion doesn't happen. I mean, even hot fusion, we have a hard time doing. Cold fusion doesn't happen. So, yes, so sometimes new experiments refute what was previously done. Sometimes it just expands the theory, and we understand the previous theory as being just a limiting case of the larger theory. Yeah. Okay.
Kepler.
Thank you all very much. And I hope that you will all read my book, because there's lots of stuff there which I couldn't talk about.
Thank you very much.
Thank you very much. I enjoyed it.
Bye-bye.
Thank you.
Thank you.
Yes, from the group, I thank you very much for your talk. Thank you.
Thank you. Bye.
Okay.